Hey, I'm Laura with RockYourWorldGems.com, and we're on Chapter 3, Scrub-a-Dub That Specimen. Disclaimer before we get cleaning. We need to make sure when we choose a specimen for these tests that we are either okay with the specimen getting a little messed up, or we don't do that test, and therefore we have less information for our scientific basis. But you need to choose a specimen to do these tests that you don't mind getting a little roughed up. If you can, like if you're out collecting, get, not like an unreasonable amount, but like some, because some of these tests could like potentially destroy it. But essentially, like, we don't want to perform these tests on like the museum specimens is what I'm trying to get across. We want to perform these tests on the ones that like are a little homelier. Your favorite, more stuff. That's right, we're gonna need more stuff for cleaning. But the first question is, does your specimen even need cleaning? So before we get into if your specimen needs cleaning, let's just go over what cleaning supplies we use to clean rocks and minerals in general. Weapon number 1, our breath. Weapon number 2, an old toothbrush. Weapon number 3, a soft paintbrush. Weapon number 4, a dental pick. Chemical number 1, water. Chemical number 2, a high quality dish soap. Chemical number 3, a specialty product found at most hardware stores, brand named Iron Out, and what it is peptic acid. Chemical number 4, oxalic acid. It is often sold at the hardware store under wood bleach, so it would be in your wood and stain section. Oftentimes the people won't know what you're talking about. The product I buy in particular is in an 8-ounce bottle of powder, but your presentation could be different. It is also one of the main chemical ingredients of Barkeeper's Friend, and a separate basin to do your cleaning in. Why? Because dirt and drains don't mix. If you're curious about the book or the worksheet, link in the bio. So does it even need cleaning? So if we have a very good prepared specimen already that is not dirty, we don't really need to do anything to it. You may want to take, like a dry cloth to it and wipe it off, but that's about it. Don't do that to the really fragile ones. That's what the is for. Then there's also something that happens to really cool rock called iron staining. And this is an example from near my mine where we can see that there are some crystals that we could identify. They're clean, but some of this is very obscured by this. Not only there's dirt on this, but there is also iron staining. Let me show you another representation of iron staining. Here is more iron staining, and you see where that black obscures certain types of minerals more than others. We're going to want to get that off of there before we try to identify what these minerals are that are underneath all the iron staining. Here's one that's still just covered in desert dirt. This is from my mine, and this has desert dirt on it. See, lichen and stuff? That's something that you would use like a toothbrush or something on if we determine that this was a specimen that was safe to use water on. But how do we do that? One last really dirty one real quick. Here's another one. Look at the staining on that. You really can't see many of the minerals in it because it is stained with caliche, which is from groundwater, which we're probably not going to be able to get off of there. But the iron staining and the dirt will definitely be able to get off, and then we'll be able to see what this is actually made of. So the first thing we want to do is check to see if your specimen is friable or if it breaks easy. So things like fuzzy crystals and crystals with an earthen texture. If it is softer than a cookie, we don't want to submerge it in water. So once again, if it is fuzzy or looks like spider silk or is softer than a cookie, and you can use your dental pick to poke at it a little bit, if it's any of those things, we do not want to submerge it in water. What we want to do is use the lightest, most light thing that we can. So maybe we blow on it, maybe we brush it with a paintbrush, maybe we get a lighter paintbrush, maybe it's a stone that we can just like hang upside down and like dangle, maybe shake the dirt out of it. But What we don't want to do is we don't want to damage the specimen. So this is a weathered specimen from my mine, and you see how the quartz, and we'll get into how I know this is quartz later, but see, the quartz is okay. But see that little guy that made the pocket originally? It was a fuzzball, and the chalcedony sat on top of it, but now through weathering, probably acid rain, my crystal is all screwed up. So if we cut into this, we might actually see what an unweathered version of this crystal is. But this crystal, since it's been exposed to the weather, is hosed. So the next thing we'd want to do is check to see if it's acid sensitive. The other thing you want to do is make sure you're not dealing with a dyed specimen. This will leach dye into your water, and so that's actually one way you can test it, is take a wet Q-tip and run it over a stone and see if any color comes off. This is especially true if you buy online or if you buy from stores. So you'll want to test that. I've had some that I put in a jar of water and it turns the jar of water pink like 17 times, no joke. It was a piece of dyed sujolite. So that's another thing you want to check for is dyes. Oh, and most salts are a no-go in water. So if something, well, if you suspect that something is in the salt family, you're probably not going to want to wash it with water. You're probably just going to want to brush it clean to the best of your ability. And not all salts taste salty, nor should you taste all salts. So, sorry, I forgot to assault you about salts. Alright, so the first thing that you want to do in order to test if your mineral specimen is sensitive to acid or to water is to get yourself a swab. And what you want to do is you want to go ahead and either take the swab or a dropper bottle. I'd said a dropper bottle in our original list, but a swab will do just fine. And what you'll do is you'll go ahead and you'll take some water and drop it on your specimen and then observe to see if there's any degradation. It might take a moment, and you might also have to, so see my little wet spot right there? You might also have to look through your jeweler's loop. Nope, I don't see any degradation, so this specimen is safe for water. Now we're going to go ahead and do a vinegar test. So you can either have a dropper bottle full of vinegar that you take with you in the field, or I have a container of vinegar here. We're going to go ahead and get a new swab. We're going to drip it into the vinegar, and we're going to choose a new place on this specimen. And we're going to choose a couple places because I saw, this is that one that I showed you, those other crystals right there. So we're going to try the quartz, well, what I think is quartz first. We'll try it on a new space right here, right on the corner. And with vinegar, I like to wait a moment. Sometimes it takes just a little while for the bubbles to start showing. So I'm going to put some right there. I'm going to put some just across from it on the crystal face. So I have some right here and some right here. So we're going to let it sit. But I'm also going to take, you see how these ones aren't all messed up? Okay, we're going to go to the messed up crystal. And we're going to put a little vinegar on the messed up crystal. Now, see me put it on there. Okay. Now we're going to inspect it with our loops and see if anything has happened on those vinegared surfaces. Well, it's cleaner, that's for sure. Okay, so on the outside, we have just a cleaner surface. On the, what I suspect is quartz, no bubbles, also a cleaner surface. Now let's take a look at that this little mineral cluster here that has seen better days. Let me get it under some light there. Well, I wish you could see this because there's little bubbles. So this is a mixture of both stone that is acid resistant, but not acid resistant. So what would we clean this with? Water, yes. We would also, because it's got iron staining, look at using iron out, but we'll get to that. Now, let me show you on a specimen of known calcite, remember this one from the other day? What that bubbling looks like. Let's see if we can catch it. So we go ahead and take a new swab so it's not cross-contaminated. Got our specimen right here. And yeah, this is clean enough, but we're testing for acid sensitivity. This is also important to just know. So you want to, as I said, we do destructive tests when we're testing rocks. So you want to go ahead and drip some vinegar on there. And as I said before, you want to wait a little bit and try to get a little puddle so that you can see if those bubbles form. Let's take a look. Ooh, looking under the loop, we can definitely see bubbles forming. Let's see if I can turn this and see if you can see the bubbles too. Ooh, that didn't work at all. I'm so sorry. So what you'll need to do is actually get yourself a little piece of calcite, drip some vinegar on it, or some limestone or some dolostone, and look for those little bubbles under your loop. So as you can see, those little bubbles start to be able to be seen by naked eye, but I could definitely see them under the loop. So calcite is not something that is acid resistant. So that's going to change our strategy on how we would clean a dirty piece of calcite. Also, rinse your specimens or the acid's going to stay on them and continue to degrade them. I have had multiple people use vinegar, use ketchup, use even iron out can potentially ruin a specimen. So you want to do a spot check and before you put your like museum quality specimens in there. Once again, destructive tests. Okay, and last but not least, you might need a fresh broken surface on a specimen to tell what it is. It's very hard to tell exactly what this is. Is it agate? Is it jasper? Is it chalcedony? Is it chert? Is it tough? What is it? I can see that there's a crystal pocket, but what's the rest of it? I don't know. This is why we see rockhounds using hammers in the field, but this was so dang pretty, I'm going to end up probably cutting it or polishing it in order to access what's in the guts here and see what I actually have. If you found this little nugget out in the field, would you think that this is inside it? No. So sometimes you need a fresh, clean surface. Okay, so now to get on to the cleaning. We've inspected our specimen. We've checked to see if it's water sensitive. We've checked to see if it's acid sensitive. We've checked to see if it's fragile or softer than a crumbly cookie, like a soft cookie. We're not talking like hardtack, but like, oh, you know, a good cookie. And we may have had to expose a fresh surface through cutting, hitting with a rock hammer, or through grinding and surface polishing. My dad was in dry cleaning, and he told me that even in laundry and dry cleaning, where you have all these chemicals, the first thing that people do is use cold water to get a stain out. The second thing is warm water, and the third thing is steam. It's all forms of water, because water is one of the most powerful solvents on the planet. Before you use hot water or steam, you're definitely going to want to make sure that your stone is not temperature sensitive. So things that are suspected to be opal or solid crystals, you may not want to actually put in steam or boiling water. That'd be a bad idea. Hot water at the most. Next, we move on to our high quality dish soap. Why do I say high quality dish soap? Because it rinses away easier. So if it has fancy words on it like platinum and things like that, it actually does work a little bit better than the cheapo depot like dollar store stuff. Pardon me, $1.25 store stuff. So we're gonna try a little scrub-a-dub-a-dub-roo with our soapy water. We might use our paintbrush, but we usually reserve the paintbrush for dry cleaning. Not like dry cleaning your clothes, but like dry, the act of dry cleaning. Or we might bust out the soft toothbrush that we tried with our water and try it with a little sudsy-dudsy water. If the soap's not doing anything for you and you feel like you have staining and not additional minerals to remove, then this is how you proceed. Now here's the big thing. Use personal protective equipment. Always cover your eyes when you're using chemicals, even the soap. I don't want to hear it. Also, the water. You don't know what's on these rocks that could get in the water, that could get in your eye, and then you could have like a brain-eating amoeba. So with things we've determined to be acid sensitive, like calcite and fluorite and things of that nature, we're going to want to use a product called Iron Out. It is peptic acid. And iron out, I have seen giant fluorite plates and calcite plates being soaked in it. But what you want to do is you want to double check and like test a specimen first. You want to check it often. Because you never know what it might etch off of the surface. I have seen crystals damaged on occasion in the past, but at the same time, I've also seen a fluorite plate the size of my desk that has been sitting in iron out solution for 3 years to pull the iron out of the stone. You can use iron out on both acid sensitive and acid tolerant stones. If in doubt, use iron out. I'm not being compensated by iron out, nor am I trying to write poetry for them. That just happened to rhyme. So, say the iron out worked. We can move on. If it worked a little bit, you may want to then try an oxalic acid bath. With the stuff from my mine, I have to do both iron out and oxalic acid. Now, with both of these products, you want to read the instructions. Iron out might cause a little bit of itching if you get it on your skin. I know it burns my nose a little bit, and you'll definitely see some bubbling in the water. The oxalic acid is a little more dangerous. You'll want to wear some gloves. You'll want to do it outside, and you'll want to make sure there's plenty of ventilation. And this isn't something that you really want to store in your house while you're going through the oxalic acid treatment. Submerge your sample in water. Add the appropriate amount of acid for the amount of water. I use 4 ounces for a 5-gallon bucket. So if you're only using a little, like 8-ounce, 16-ounce pint glass, you're talking about teaspoons. And I use a warmed water to help mix that acid into the water. You want to leave it in the acid until it stops producing bubbles and results. You may need to refresh your acid bath if there were a lot of mineral deposits on it that you've been taking off. You can also use these acids to remove minerals that you don't want on your specimen. So say you have known calcite on some known agate or chalcedony. Well, you could soak that chunk in oxalic acid for a very long time, and it would eat away all those crystals that you don't want, the acid sensitive ones. So you can use acid as your friend as well. So personal protective equipment. Big deal. Remember that working with acids, dilution is the solution to pollution. So when you're done with it, add lots of water. And that's also what we're going to do with our rock. So for every day that it's spent in acid, we are going to soak it for 3 days. Every week, we're going to change our water. So you can soak some things in iron out for years to get deep, deep stains out. And then you're going to soak it in water for 3 times as many years. It doesn't matter if you use oxalic, barkeepers, peptic acid, vinegar, soap. Just make sure that you soak your mineral in water, if it's water tolerant, because this is all water tolerant we're talking about, for 3 times as long as you had it in a cleaning solution. Especially if you're going to make jewelry or display it for the long term. You do not want degradation or itchy skin. So there you have it. Basic specimen preparation, getting ready to identify what it is. So if you like what I said, you want to hear more, I got a whole playlist. We're going to do all 14 chapters plus on how to identify rock and mineral. Hit the like, subscribe, plus whatever button, link in the bio, wherever you find that, to get the book and the worksheet that I'm talking about. Now, all the things that we did today, you'll want to document on your worksheet. Sensitive to water, sensitive to acid, what cleaning methods used. You want to document this on your specimen worksheet. For more information on the worksheet, find my bio or go to rockyourworldgems.com. Oh, and make sure to hit me up with any questions. I love questions.